Hello, I'm Jason and I'm third year in the undergraduate Applied Mathematics and Statistics program. For the final project, I'm working by myself on an interesting problem. Can we predict heart failure based on publicly accessible data? This is important because heart failure is a major global killer and early detection could save many lives. To do this, I'm using a dataset from Kaggle which has 13 variables including a dependent variable. The dependent variable is binary, which means logistic regression is a sensible model to address this problem. The dataset has only 300 observations. The independent variables include binary variables, discrete variables, but also one continuous variable. This is the model diagram. Normal priors are used because regression parameters are continuous and exist in the interval of negative to positive infinity. The Bernoulli likelihood reflects the dependent variable being strictly binary, and this will help to model the dependent variable as a distribution. I'm going with the assumption that there is no prior information. My first question was, do any variables correlate strongly? This would allow me to eliminate variables easily. To compare the numerical variables, the standard correlation coefficient was used. But for binary to binary variable comparisons, I used the Matthews correlation coefficient, and for numerical to binary comparisons of correlation, I used the biserial correlation method. I couldn't find a nice way to visualize these correlations together, so I made a function that does the appropriate correlation method for each pair of variables based on whether they're both numerical or both binary or a combination. Then I made this heat map. Each label has its variable type as either N for numerical or B for binary. All results showed a correlation of 0.4 or lower, so there's no good reason yet to drop any variables. To see if we can drop some variables, I used R and JAGS to construct a model that uses all variables. The resulting posterior plots should give me some ideas about what I can keep. I eventually found some settings that lead to good diagnostics. Here we can see in every case that the chains overlap, autocorrelation is low, and the shrink factor is below 1.1. Not all diagnostics are shown here because there are 13 variables and they're all much the same. Once I was satisfied this had gone well, then I plotted the posteriors together. Several of these posteriors show that 0 falls almost in the middle of the distribution. For the 5 variables of anemia, diabetes, high blood pressure, platelets, and smoking, there was insufficient evidence to reject the null hypothesis that the parameter values are 0. So these variables won't be included in the final model selection. Another 4 variables are just inside the 95% HDI, so final model comparisons will test models that include at least 4 and at most 8 of these parameters. This is as far as I've gotten so far. The next steps will be to run several models at the same time with different combinations of the remaining parameters. I will add some predictions to the model to evaluate the success of each model, and then I can use a Bayes factor analysis and sensitivity analysis to determine the final model. Thanks for listening.